guys, can you hear me? Can you see me? Please let me know. Hello boys and girls, can you see me? Can you hear me? Please let me know. I am sorry for this delay, man. Sorry for this delay. How are you guys doing? A very good evening to all of you. What's up? What's happening? Please let your friends know that we are here. I'm taking a live class after a very long time. So please, I'm excited. Please, come back if you were gone somewhere. We are starting our session now. We are starting our session. All right. Amazing. Chalo. So yes, let's start the session. I am live here and I am feeling energetic today. Let's have our session starting and let's have our session going on. So all right, so it will be on CFT. It's on CFT of tetrahedral complex, and we'll also learn isomerism. So okay, let's hop into it without wasting any time. I'm Harsh Maheshwari. I'm from NIT Varangal, and I believe in one thing, that jo karo maze se karo. So let's have a beautiful session. Let's have a beautiful session. And yes, please make sure you subscribe to our channel so you will be notified when when the video is going live, so you can watch it just like this. Okay? All right. So our topic is CFT, crystal field theory, and we will do it for tetrahedral complex, and also we will learn isomerism. Okay? Right. I am starting it without wasting any time. Okay, beta, starting it now. So crystal field theory for tetrahedral complex. देखो दे बच्चा. In tetrahedral complex, coordination number is 4. It means there are 4 ligands. There are 4 ligands. Now, how these ligands will approach the system, let us understand. The ligand will come from alternate axis. Here, 4 ligands are there, and they are going to come from the alternate axis. Basically, 4 ligands will come in this particular XY plane or XYZ plane, but they will come from 4 different directions, and that to be they will be coming from alternate axis. If one ligand is coming from here, another ligand will come here. If this ligand is coming here, then another ligand would come just here, right? As a result, another ligand would come here. So basically there are 4 ligands, and these 4 ligands are approaching in alternate manners. Okay? In an alternate manner. Very important point. Now you can notice, since ligands are not coming along the axis, like in the case of octahedral, in the case of octahedral complex, what was happening? Ligands were coming along the axis. But here it is coming, the ligands are actually coming in between the axis and from the alternate axis. As a result, beta, what will happen? Check this out. Check this out. What will happen here? So this one is dx square y square. Do not get confused. This is nothing but dx square y square. Acha. As a result, beta, what will happen here? The energy level of dxy, dyz, and dzx would be more than the energy level of dx square y square and dz square. This is called as T2 level here, and this is called as E level. G is not used here. G is not used here. यहाँ पे G इस्तेमाल नहीं होता. Are you guys understanding what is happening? The lobes are coming. The lobes are coming in between the axis from the 4, or I should say from the alternate, in an alternate manner. The ligands are coming in an alternate manner, and they are coming in between the axis. Whereas in the case of octahedral complex, we have seen, it comes along the axis. As a result, here what happens, dxy, yz and zx would be of higher energy, and that particular set we are calling as T. We are calling as T. T2. And the set of dx square, y square and dz square we are calling as EG. Is this point clear? क्या बेटा ये बातें समझ आई? Is this point clear? It's a very important point. It's a very important point. I hope it is clear to everyone. सबको समझ आ गया है ये point. ठीक है बेटा? Let me know in the chat box. So there will be, this is your energy distribution. This is your energy distribution for tetrahedral complex. T2 level is up and EG level is down. ठीक है? The set of dx square, y square and dz square is called as EG. The set of this, and the set of dx square, y square, dxy, dyz and dzx is called as T2 set. बहुत बढ़िया. अच्छा, अब इधर भी CFSE निकालना हो तो बेटा CFSE लॉजिक इज सेम. This is nothing but your Berry center. from here to here, or if I say this is nothing but tetrahedral splitting. From here to here it is plus 0.4 delta T, and from here to here it is minus 0.6 delta T. So if I have to apply CFSE here, so what I will write, T2 and number of electrons in T2 level plus 0.4, ये del T हो जाएगा बेटा. This will be del T. Here it will be del T. Correct? Similarly, minus 0.6 del T plus 0. ठीक है? I hope it is clear. सबको समझ आ गया. Same logic what we had seen in the last session. CFSE we can calculate now. Important point about here, beta. Important point here. In tetrahedral complexes, all the ligands are weak. All the ligands are weak, and none of the pairing is caused by the ligand. We have done this in the previous session, so it's quite clear, right? In your tetrahedral complex, ligands, all the ligands are weak, and all the pairing is natural, right? Is actually all natural pairing are happening. Pairings are happening. Ligand is not causing any kind of pairing. Very good. बहुत बढ़िया. आगे बढ़ेंगे. Next on, moving on. ठीक है? Let's move on to the next session. आगे बढ़ेंगे. Next point. Now, very important point. Now, which splitting is more, octahedral or tetrahedral? Now, the point will come. Which splitting is is more impactful or is having more energy? So basically, octahedral splitting is more. Let us understand the reason. देखो बेटा, in octahedral complex, 6 ligands are coming and approaching the metal ion. So the repulsion caused by the 6 ligand is more as compared to 4 ligand. In the case of tetrahedral complex, how many ligands are approaching the metal ion? 4 ligands are approaching the metal ion. I hope the point is clear. So this is point number 1. So if you notice, as we move from octahedral to tetrahedral complex, there is a switch or there is a decrease in the splitting by by the amount of 2/3. Yes, इसी के थ्रू से हमारा splitting है वो कम हो गई 2/3 times. The splitting has reduced 2/3 times, right? Because in the case of tetrahedral complex we have 4 ligands. In your octahedral complex we had 6 ligands. And moreover, second point, in octahedral complex what happens? 6 ligands are coming from 6 direction, and that too coming from they are coming along the axis. They are coming along the axis. So splitting was very efficient. In the case of tetrahedral complex, ligands are not coming along the axis. They are coming in between the axis, and they are not pointing directly at the ligand or the metal ion. I'm sorry. The ligands are not pointing directly at the metal ion. They are coming, yes, they are coming in between the axis, but not directly there. So repulsion caused by it is less. First of all, two reasons. One reason is that there are 6 ligand in octahedral complex, 4 in tetrahedral. As a result, splitting decreases 2/3 times in the case of tetrahedral complex. One reason. Point number 2, 6 ligands were coming from 6 different directions and they were coming along the axis. But in the case of tetrahedral, only 4 ligands are coming and they are coming in between the axis, and these ligands are not pointing directly at the metal ion. So repulsion caused by this also decreases 2/3 times, right? So if you see, so it means octahedral splitting is nothing but 2/3 into 2/3 into del T. So nearly octahedral splitting is nearly 4/9 times of tetrahedral splitting, right? I hope the point is clear. Or if you go exact, it is 0.45. It is del naught is equal to 0.45 del T. ठीक है? This is exact. Is this point clear, boys and girls? सबको बात समझ आ रही है? सबको बात clear हुई? What is this happening here? Yes. बहुत बढ़िया. ठीक है जी. आगे बढ़ेंगे. तो हमने CFT पढ़ लिया है इस चीज का. बहुत बढ़िया. आगे बढ़ते हैं. तो just a quick revision. Just revise कर लो एक बार. Quickly we will revise. That square planar was the highest. We had done it. Then octahedral, then tetrahedral. Names of tetrahedral splitting, right? So we have now the exact data with us. Is this point clear? सबको समझ आ गया बेटा? Right? All right, आगे जाता हूँ. Moving on. Now moving on, boys and girls. This point I had already explained in the previous session. Whenever you have 3D8 configuration and a weak ligand, this is a beautiful weak, it will always go for tetrahedral. On the other hand, if you have 3D8 configuration and you have a strong ligand and coordination number is again 4, it will go for DsP2 hybridization. Square planar complex will come. Is this point clear? We had done it, right? We had done it. I just revised it so that you can recall it. All right. बहुत बढ़िया. सबको समझ आ गया बेटा? सबको clear? Is this point clear? Let me know in the chat box कि यार सर समझ आ रहा है. I am coming live, after a very long time. So I hope you are understanding each and everything. हाँ, काफी सही, काफी सही. Please let me know. बहुत बढ़िया, ठीक है. एग्जाम्पल के तौर पे देखिए, लेट अस डिस्कस दिस. निकल इज नथिंग बट 3D8 4s2, and nickel is existing in +2 state in this particular complex, so it will become 3D8. Cl minus, boys and girls, is a weak ligand, so 3D8 plus weak ligand is a deadly combination. This is your 3D, this is your 4s, this is your 4p. So 1, 2, 3, 4, 5, 6, 7, 8. None of the pairing is caused by ligand. Ligand is not that strong to cause an extra pairing. So what will happen? These orbitals would be used. It will pair of electron to this particular vacant orbital. Is this point clear, beta? सबको समझ आया? Is this point clear? I hope I can, I'm able to reach every one of you and you're understanding. क्लियर है? तो ट्रिक क्या है? 3D8 plus weak ligand always, always, always will give us tetrahedral. Correct? बहुत बढ़िया. Easy. I'm liking it. I'm liking it. Now moving on, beta, the most important part of this chapter. From this topic, JEE asks many questions. Many questions had appeared previously. I will discuss few advanced questions also. Do not worry. In next session also. And today we will do some amazing isomerism. We will understand it. And also wait up. Please make sure you follow my lectures. Tomorrow I'll discuss some advanced questions in the classroom itself. ठीक है? तो मैं क्लास में डिस्कस करूंगा. All right, let's start. Now, what is isomerism in coordination compounds? What is isomerism in general? The compounds, two different compounds having same molecular formula, or I should say two compounds having the same molecular formula, but different arrangement, different connectivity of the ligands with the central metal ion. I repeat, बड़ा simple है, no bookish definition required. No bookish definition required. Simple one logic. जब कभी भी, whenever you will see ligand, two compounds, first of all, having same molecular formula, but different connectivity of the ligand with the metal ion. Different connectivity of the ligand with the metal ion, then you understand, okay, it means it must be isomerism. Now, isomerism is of two types. It is of two types: structural isomerism, stereoisomerism. Let me explain one by one. So basically, what is isomerism? Compounds having same molecular formula but different connectivity of the metal ion with the central metal ion. If this connectivity is causing difference in structure due to different connectivity, there is a difference in structure, then you say, sir, it is structural isomerism because of the different connectivity, or because of the this connectivity issue, or the connectivity of the ligand with the metal ion is different. It is giving you two different structure, but yes, molecular formula is same. You will say, sir, it is structural isomerism. It is structural isomerism. Stereoisomerism is quite different and quite interesting. Here, molecular formula in two compounds, the molecular formula is same, but the connectivity is in such a way that three-dimensional. If you look it in space, when I say space, when you look that particular compound, when you look at that particular compound in space in 3D, it will have different orientations in space. It will have different connectivity of the ligand with the metal ion in 3 dimension. 3 dimension की जैसे ही बात हो जाए, whenever we talk about 3 dimension, it means we are talking about stereoisomerism. And when we are talking about structural change on the same plane, we talk about that it is nothing but structural isomerism. But whenever this connectivity is going 3 dimensionally, this connectivity is giving you different structures in space in 3D, then we call it as stereoisomerism. Is this point clear? क्या बच्चों समझ आ रहा है? Let me know in the chat box. I am waiting for a minute and I will answer your doubts if you will ask me any. जवाब बोलो बेटा, क्या जवाब चाहिए आपको? बोलो बेटा जल्दी से बोलो. सिस और ट्रांस के बारे में बात करेंगे. वेद काफी जल्दीबाजी में है बेटा, तू काफी जल्दीबाजी में. इतनी जल्दीबाजी नहीं, अभी तो स्टार्ट किया है और मैं अभी स्ट्रक्चरल पढ़ाऊंगा. आकांक्षा अभी क्या बातें कर रहे हो? मुझे लगा किडनैप हो गए थे. क्या लॉजिक है इधर? ऑलराइट, फोकस. ठीक है, सबको समझ आ गया है? ऑलराइट, काफी बढ़िया. ठीक है, अब मैं बढ़ रहा हूं आगे. ठीक है जी, अब सुनो. स्ट्रक्चरल आइसोमेरिज्म अब हम डिटेल में पढ़ रहे हैं. वी आर स्टार्टिंग स्ट्रक्चरल आइसोमेरिज्म इन डिटेल. सो बेटा, व्हाट इज आइसोमेरिज्म? When you will see two compounds having the same molecular formula but different connectivity of the ligand with the metal ion. If this connectivity of this ligand with the metal ion giving you two different structures altogether, but yes, you know, your molecular formula is same but different structures are there, you will say it is structural isomerism, right? From the name itself, it is quite evident, quite clear. The name is a testament itself. हाँ, बड़ा सिंपल सी बात है. तो बेटा, what will happen due to difference in structure of complex or connecting groups, right? ठीक है. So it is of various kinds. We'll deal with them one by one. We'll talk about them one by one. Check this out. First one, ionization isomerism. So structural isomerism, first category is ionization isomerism, one of my favorite kind. In this particular isomerism, you will see different number of ions or type of ions obtained. When you will dissolve your complex in water, you will see there is a possibility of different types of ion. You know, you will be getting or you will be obtaining different types of ions or different number of ions, right? Let me show you. Check this out. PT ammonia Cl2, after the square bracket there is bromine, right? There is bromine. Check this out. Very interesting, very intriguing. So beta, what will happen? Check this out. It will become on the sphere +2 charge will come and it will give you 2 bromine, Br minus. There is also a possibility, this is nothing but your counter ion. हमने बात करी थी counter ion की. It is the ionizable part of your coordination compound. One of the Br can go inside the coordination sphere also. There is also a possibility for that. And one Cl will come out. So now you are getting Cl minus Br minus. From the same complex, you are getting different type of ions, right? So these are 3 different complexes. 1, 2, 3. Everything is same. If you notice, molecular formula is same for all the 3 complexes. 1, 2, 3, molecular formula is same for all the 3 complexes. Molecular formula is same. Molecular formula हर जगह same है, ठीक है? But in first one you are getting 2 Br minus. In the second one you are getting Cl minus Br minus. So different type of ion is produced, right? A different type of ion was produced, that is Cl minus. And in last one, again you will get 2 ions but 2 Cl minus ions. So whenever you are able to produce more than one type of ion or different types of ion or different number of ions, then you will. Yes, boys and girls. बता दो बेटा जल्दी से. ठीक है. All right, moving on. Next one. Next one is also very interesting. Next one, pay full attention. Beta, in structural isomerism. Now next one, we are going for second category. Hydration isomerism or hydrate isomerism. Here also what you will get different number of H2O. When you dissolve your complex, you will get different number of water molecules coming out from your complexes. So there is a difference in number of water molecule in outer sphere. Check this out. There is a difference in uh, yeah, boys, can you hear me? Can you hear me?